Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we're going to summarize some of the top stories in science and also answer some questions about science that I get in emails. There's no way I can answer all the emails that come in, so I'll answer them collectively on Exploration. First of all, let's jump right into some of the top news. Well, we have two pieces of news coming from two different parts of the world at the same time. First of all is the inauguration of President-elect Donald Trump, who made it official that he is in fact the President of the United States. And second of all the way out in Europe, we have the meeting of the World Economic Forum, a forum in Davos, Switzerland, that some people say is completely obsolete and out of sync with the times. Davos stands for globalization, free trade, technology, and prosperity, they say. However, it seems to be on a collision course with Brexit, with anti-immigration forces in Europe, and also with the inauguration of Donald Trump. And so what's the link? Well, I'll tell you what I think the link is. The link is science and technology and how we deal with the revolution taking place in science. And then let's say a few things about outer space. First of all, good news for SpaceX, the company spearheaded by Elon Musk. Several months ago, they had a disastrous explosion of their rocket. Now, they topped it with a successful launch of their rocket. However, speaking about rockets and the weather in outer space, we have bad news from the Earth itself. NASA satellites and data have now confirmed the fact that 2016 has gone down as the hottest year ever recorded in the history of science since 1880, when records were first kept, making it the third year in a row where we had record heat waves hitting the world on average. And we're going to talk about what that means in light of President Donald Trump's cabinet choices that are now undergoing confirmation in the United States Congress. And then we'll say a few things about the moon and Mars. It turns out that, yes, more evidence is coming out about the formation of the moon. Meanwhile, NASA is setting its sights on the planet Mars. And then we'll take a few listener phone calls. So once again, let's just jump right into some of the top stories of the past year. First of all, 2016 went down as the hottest year ever recorded in the history of science since records were kept starting in 1880. Though, of course, we can go back even earlier than 1880 by looking at ice cores. By drilling into Greenland, by drilling into the ice, we can sample snow and ice that was laid down hundreds of thousands of years ago. In fact, we can almost go back 1,000,000 years into the past. When we find that, yes, there were episodes when the temperature of the Earth was quite high and carbon dioxide levels were also quite high, and they go up and down like two parallel roller coasters. If you look at the history of the Earth going back hundreds of thousands of years, and you calculate carbon dioxide levels and temperature levels, yes, there is a direct correlation, like two roller coasters going up and down in sync. When carbon dioxide levels go up, temperature also goes up, and we see a gradual warming of the Earth since the end of the last glaciation 10,000 years ago, but a spike in rising temperature and rising carbon dioxide only within the last 50 to 100 years. And that's why one of President Donald Trump's nominees actually said before Congress that, yes, global warming, it appears to be real. Now, of course, he hesitated on the question of how much confidence we put in some of these computer models, and also how much comes from human activity versus natural cycles. However, he was very clear that, yes, global warming is taking place. And we see that not just in record-breaking temperatures of 2016 and the last 3 years, we see it everywhere. First of all, every major glacier on the planet Earth is receding. And we see dramatic photographs taken by satellites decades ago compared to pictures taken yesterday, and we see a recession on every level of all the major glaciers of the past. For example, when school children read Hemingway's famous novel, The Snows of Kilimanjaro, they'll ask the question, well, gee, I thought Mount Kilimanjaro didn't have any snows at all, because all the mountain caps, seem to be losing their ice cover. And so, yes, we see a recession of the glaciers of the Earth. We see an increase in the average temperature of the planet as taken by satellites. We see on every front the fact that the Earth is heating. For example, the seasons are thrown out of kilter. Summer is about a week longer than normal, which in turn affects the growing cycle. Farmers, of course, have to know this, otherwise they'll plant their crops at the wrong time. Not to mention the fact that tropical diseases are spreading north because of the warming of the Earth. It means that mosquitoes have a more hospitable environment as they start to move north. And look at Antarctica. As we reported earlier on Exploration, a gigantic crack is forming right before our eyes, accelerating in the month of December of last year. And it means that the Larsen Ice Shelf Sea will eventually break off. An area the size of Delaware will break off from the South Pole, and that'll expose in turn more and more of the inland ice to warmer waters. And it means that we're witnessing something that climatologists did not think would happen in 100 years, and that is the slow breakup of the South Pole. And of course, we don't expect the South Pole to completely melt anytime soon, but if it were to melt, then the coastal regions of the United States would be totally underwater, and the map of the United States would have to be totally redrawn. Where I'm standing right now in Manhattan will probably be underwater if we have a further melting and cracking of the South Pole. So, we also have a very strange juxtaposition of two events taking place on two places on the planet Earth. On one hand, we had the inauguration of Donald Trump in Washington, D.C. But also in Davos, Switzerland, we had the meeting of the high mucky-mucks of the World Economic Forum. Now, let me give you a full disclosure. I spoke in Davos last year talking about the future of technology and the future of energy, and it was quite a sight. We had prime ministers, presidents of different nations showing off their economic and political prowess. Not to mention the fact that there were guards, hundreds of guards with machine guns everywhere you look, especially because several prime ministers from rather controversial nations were attending the conference in Switzerland. And what were the topics? The topics was technology, not to mention the hallmarks of Davos, which is free trade, globalization, and technology. So we have two events taking place, two places on the Earth with diametrically opposed points of view. On one hand, we had Donald Trump saying, bah, humbug. Free trade means unemployment. It means freedom to move factories to Mexico and overseas. And look at the white working class. They're being bled dry, even as the high mucky-mucks, for example, in Davos, Switzerland, the billionaires, are raking it in. So that's being said in Washington, D.C., and far away in Switzerland, a different tune is being played, and they are talking about the benefits of globalization and the benefits of free trade. Free trade makes possible the interaction of goods and services, meaning that prices will drop with free trade, tariffs will drop, increased movement of goods and services, but not to mention the fact that rise of super billionaires is also a consequence of this. Many of the goods and services are being exchanged across the earth, which is a good thing, but the byproduct is that most of the profit from this goes up and not down. And we see the effects of it, the hollowing out of industries. Now, on one hand, some people say it's too late, that science and technology don't halt all of a sudden just because of some politician's statements. You cannot stop progress, and therefore stopping free trade is like sweeping back the oceans. People on the other side now, wait a minute. If the top 1% benefit, yes, it turns out that technology will lower prices, increase the flow of goods, but the profits from the increased flow of goods goes to the top. So how do we make sense of all this? Well, as I said on Exploration a few weeks ago, I look at it from a scientific point of view. Because where does wealth come from anyway? Yes, it comes from labor. Yes, it comes from entrepreneurs, far-sighted government businessmen and businessmen. So where does wealth ultimately come from? Ultimately, it comes from science and technology. But science and technology come in waves. The first wave of wealth creation coming from science and technology was the steam engine, the coming of the Industrial Revolution and the locomotive. And all of a sudden, when physicists and scientists worked out the laws of thermodynamics, we could calculate how much energy and profit you can extract from a lump of coal, and that made possible locomotives. It made possible steam engines, factories, and the Industrial Revolution was off and running, and a byproduct of that was the creation of the industrial working class. All of a sudden, you had peasants rushing into the cities, getting jobs as factory workers. That was the first wave of science. The second wave of science was the coming of electricity and magnetism and the internal combustion in the early part of the 1900s. All of a sudden, you had tremendous wealth coming from utilities and automobiles, creating a huge wave of wealth creation. Now, the first wave of wealth creation, we should point out, created a bubble. A huge bubble on the London Stock Exchange and railroad stock, culminating in the crash of 1850 and subsequent crashes. So in other words, the wealth created from the steam engine had an unwelcome byproduct, and that is a bubble which popped in 1850. In fact, the crises of capitalism were so severe because of the inefficiencies and unevenness in the generation of wealth from steam power, that it created a backlash. In fact, the backlash was the creation of Marxism. So Marxism on one hand and the formation of the industrial working class on the other were byproducts of the introduction of the steam engine, thermodynamics, and the Industrial Revolution. Now with the coming of electricity and magnetism, we had another bubble, a bubble in utility stock and automobile stock. These two bubbles could not be sustained, and they popped in 1929, creating the Great Depression. And one of the byproducts of that was the creation of large industrial unionism. Now, unions, of course, existed even before then, but the formation of humongous unions like the AFL and CIO were a byproduct of the backlash to the bubble, which created, of course, the Great Depression of the 1930s. The third wave of wealth, also unleashed by physicists, was high technology. The creation of the transistor, the laser, the space program. All of a sudden we have high-tech gadgets generating a telecommunications industry, a satellite industry, and that creates an even bigger bubble of wealth. And that wealth went into, well, in America, real estate. And that bubble popped in 2008. But you see, each of these bubbles changes society. Each of these waves of wealth creation. The first wave of wealth creation created the industrial working class. The second wave created the modern union movement. That was the second wave of wealth creation. The third wave of wealth creation created globalization, created an emphasis on free trade, and a weakening of the unions and a rise of the service sector. Now we're headed for the fourth wave. The fourth wave, where we have artificial intelligence, the maturation of biotech and nanotech, which is again going to change the political and economic landscape. And that's what the election of Donald Trump is all about, and the crisis affecting the Davos Conference on globalization and free trade. The third wave was typified, as I said, by globalization, by the increase of wealth creation, by free trade, and also the creation of a super wealthy 1% class. Yes, about 1/3 of America benefited from this, not just the 1%, to be fair. About 1/3 benefited from this in the last 15 or so years. But unfortunately, about 2/3 of the American workers either held steady or begin to actually retreat in terms of economic progress. And that, in turn, roughly compares to the 1/3 of the American population that finish college, and 2/3 that don't. Of course, that correlation is not precise, but the correlation is relevant because it shows that education is closely tied to wealth creation because the third wave is technological. That is, we're talking about high tech in the form of computers and lasers. And then the question is, what do we do about it? Well, some people say we have two extremes. On one extreme, we have some people who want to roll back the wave of science and technology, which will, of course, make products more expensive. But who knows? Some people say that it's worth it. On the other hand, we have the bulldozer of free trade and globalization, which does create wealth, but wealth unevenly distributed, and wealth that does not necessarily raise all boats, as they say. Well, my personal point of view is that we should, first of all, emphasize education. As I pointed out, the 1/3 that have benefited from all this high technology are largely college educated. And we should make sure that we don't leave anyone behind when we start to put an emphasis on education. Next, new industries. Yes, it's true that some industries are gone. We don't have blacksmiths anymore. We don't have wagon makers anymore. But we don't cry about it because other industries were created to replace the horse-driven carriage. And so we have to have government funding of new industries, new sources of wealth. Now, politicians, of course, don't want to do this because for them, it's all about winning elections and simply cutting the pie thinner and thinner, that is, taxing Peter to pay Paul, which I think is a zero-sum game because, of course, you're not creating new wealth. You're simply rearranging the wealth by cutting the pie thinner and thinner. Now, I'm a scientist. I'm a physicist. I believe in creating a bigger pie. Now, some people come up to me and say, Professor, what has quantum physics done for me lately? How has numero uno benefited from quantum physics? And so I tell them that, well, we quantum physicists invented the transistor. We invented the laser. We wrote the World Wide Web. We helped to assemble the Internet. In fact, much of the wealth of Silicon Valley, the wealth of companies like Apple Computer, one of the biggest companies in the earth, comes from quantum physics. Not to mention that we physicists invented television. We invented radio, radar, microwaves. In the hospital, we invented the X-ray machine. We also invented the MRI scan and the PET scan and the EKG. And don't forget, we also helped to create the space program and the GPS satellite and weather satellites. All of it from the minds of physicists. But we physicists are restless. We're creating the next generation of wealth-creating technology, but it requires funding and lower taxes for entrepreneurs to make sure that these technologies flourish. And so, yes, Donald Trump has a point there. We should decrease regulations and decrease taxes, especially on those entrepreneurial companies which are wealth creators. Now, we'll see what eventually happens. Perhaps some kind of compromise could be made between the Davos people, that is the billionaires who are pushing free trade and globalization, and the people behind Donald Trump who see the excesses of globalization when it hollows out the American working class. We'll see how it plays out. But my point of view is very simple, and that is science ultimately is the creator of wealth in society, and science has to be nurtured. We have to nurture young scientists with education. We have to nourish young entrepreneurs who want to market the science and create jobs into the workplace. And also we have to make sure that governments fund R&D research, because R&D research is ultimately the origin of where much of the world's wealth comes from. And speaking about the world's wealth, asteroids, the moon, the space program is constantly in the news, especially since NASA last year said flatly that Mars is the next destination. However, we're going to go to the moon first and then use that to go to Mars in a three-step program. The first step is to test the SLS booster rocket and the Orion space module. That's the first stage. Second stage is to have a test run of this system and send it to the moon. So yes, we're going to go back to the moon as we prepare for step 3. And step 3 is on to Mars. And who wants to go to Mars? Well, NASA has stated that, yes, we're going to be on Mars. People will be on Mars sometime after 2030. But Elon Musk, not to be outdone, says SpaceX is right there with this modified Falcon rocket. Well, last year we had the bad news that one of SpaceX's rockets blew up, and it was a setback. The paperwork from that clearly shows that stock prices went down, confidence in SpaceX went down, that perhaps some of the luster behind the billionaire Elon Musk was tarnished as a consequence. But hey, last week they just had a successful launch, and so perhaps it's back on track. Back on track for what? NASA has stated that not only are we going to go back to the moon, but we're also going to go to the asteroid belt. And this is where the economics could change the other direction. The economics of space travel are not very favorable. It's extremely expensive to send anything into orbit, basically $10,000 a pound to put anything just to spin around the Earth. Forget about the moon. That would cost on the order of $100,000 a pound to put something on the moon. But why not mine an asteroid? This sounds like something straight out of science fiction. However, now NASA is seriously looking at unmanned probes which are going to go to the asteroid belt or passing asteroids, analyze them for economic resources. Some people think that asteroids contain large numbers of platinum and platinum-based metals and alloys, and who knows? It may be possible to send a rocket, land on an asteroid, sample the content to find out whether or not it's economically viable to mine an asteroid. And then one proposal is to have the rocket land on the asteroid and perhaps nudge it so it begins to orbit the moon or orbit the Earth, and then at leisure we begin the process of analyzing the asteroid and beginning the process of mining it, perhaps with robots or with hardy astronauts. And so that could change the economics of space travel and make it economical. Many people have a valid criticism. Yes, we should go to Mars at some point, but it's awfully expensive. Perhaps $1 million a pound to put anything on the surface of Mars. And who needs that in a time of economic austerity? Well, some people are saying that the dividends of going to Mars could be enormous, because after all, much of the computer technology of today comes from the space program, especially the process of miniaturizing transistors. The boost for that came from the space program. And look at what weather satellites and the Internet do for us today. It's unthinkable to live in a world without the space program. So some people are saying that, well, yes, the benefits are great, but we got to reduce the cost, and perhaps one way to reduce the cost is to mine the asteroids. And speaking about the asteroids, the scientists are taking a closer look now at the moon. We're going to go back to the moon as a stepping stone to going to Mars, and we're taking a look at the moon from a new point of view. And that is, we need the moon. The moon stabilizes the spin of the Earth. Otherwise, the Earth would have wobbled and perhaps even tipped over billions of years ago. We're blessed with a large moon. A large moon helps to stabilize the Earth so the Earth's orbit doesn't wobble and it doesn't wobble on its axis. Now, Venus and Mercury have no large moon. In fact, they have no moon at all. So this means that at some point in the past, perhaps Mars and Venus did wobble. Perhaps maybe they even flipped over as a consequence. And so it means that we're blessed with a large moon that can stabilize the orbit of the Earth. And also, we now know more or less where the moon came from. There's an old theory that says that perhaps an asteroid plowed into the Earth about 4.1 billion years ago. an asteroid the size of Mars, blew out the inside of the Earth and sent it into outer space, where it gradually condensed over many millions of years. Back then, the Earth did not look round. Back then, the Earth looked like Pac-Man, that is, with a huge pie-shaped section gouged out of it. But there were some criticisms. Some people said that the moon has very little iron in it, even though the moon is chemically almost identical to that of the Earth. The Earth has a huge iron core. It gives us our magnetic field. The moon does not. So if the moon came from the Earth, then how come the moon has no large iron core and no large magnetic field? Well, the answer is, as we now believe, the asteroid that struck the Earth about 4.1 billion years ago was a grazing blow. It was not a direct hit. As a consequence, the core of the Earth was largely intact, and only a piece of the iron core of the Earth was blown into outer space, and that explains, A, why the Earth still has its vibrant iron core, giving us a magnetic field which protects the Earth from the sun, and second, it would explain why the moon does not have a large magnetic field, because it was a glancing blow. So in other words, all the pieces seem to be fitting together rather nicely. Yes, the moon did come from the Earth. We need the moon to stabilize the Earth's orbit, and one day we may use this information to mine the moon as well. Now, let me also answer a question that I often get in my email, and that is, why bother to go into outer space at all? I mean, it's expensive, it's dangerous, and do we really have to go to Mars? Well, my own point of view is as follows. First of all, in the long term, we're talking now millions to billions of years from now, it's inevitable that we're going to have to leave the planet Earth. It's too dangerous, given the fact that we have asteroid impacts, meteors, comets, not to mention the fact we have earthquakes and ice ages, and also the threat of global warming. And eventually, on a 5 billion year time scale, the ultimate death of the Earth itself as the Earth goes into the sun. The Earth came out of the sun about 5 billion years ago and will go back into the sun in that same amount of time. Now, that's on a large time scale that we have to leave the Earth. However, on a more closer time frame, we also realize that the enormous benefits of the space program. I mean, think of all the electronic wonders that we take for granted today, the internet and all the appliances that we have. It's unthinkable to live in a world of 100, 200 years ago for people living today. And we can thank the space program for that. And so, in other words, with the space program comes high technology, technology that can reduce human labor, increase human efficiency, and cure diseases as well. And so there are an enormous number of byproducts, beneficial byproducts to the space program, not just waving at astronauts in outer space. Well, I'm afraid that's it for the first part of exploration. In the second part of exploration, we'll talk about, well, outer space and life. Does life exist in outer space? And what about the people, the physicists, who are looking for signals from intelligent life forms? We're going to bring on our friend Seth Shostak, director of the SETI project, talking about intelligent life in outer space. In fact, some people ask the question, is there intelligent life on the Earth? Well, maybe not. So anyway, we're going to talk about intelligent life in the universe with our special guest today, Dr. Seth Shostak of the SETI program. Welcome. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is the second half of Exploration. In the first half of Exploration, we talked about, well, politics and science on the planet Earth. We have on one hand the high mucky-mucks of globalization gathering in Davos, Switzerland at the World Economic Forum, talking about the benefits of globalization, the benefits of free trade, and however, to be fair, most of the benefits go to the top 1%, even though, of course, free trade does generate economic activity. On the other hand, we had the inauguration of Donald Trump, who was singing a very different tune, stating that globalization has benefited the few, but has basically hollowed out American industries to the detriment of the white working class in the United States. Well, some people may ask the question, is there intelligent life on the earth? Well, with us today to answer that question is Dr. Seth Shostak, director of the SETI Institute in Mountain View, California. These are the people who are actively looking for aliens in outer space. This is for real. Dr. Seth Shostak, an acquaintance of mine, has a PhD in physics, like myself, and he has devoted himself not to look at the mysteries of atoms and quanta and the universe, but the mysteries of, well, intelligent aliens in outer space. They have a huge bank of radio telescopes, and these telescopes are tuned to stars that are hundreds of light years from the planet Earth, and they listen for signals of any alien life form that may want to communicate with us, or perhaps we can eavesdrop on some of the conversations that already exist. Well, some people think, including members of the United States Congress, that this is a total waste of money. Well, perhaps. But I'm a scientist. I keep an open mind. And, hey, who knows? Maybe one day they'll pick up a signal from an intelligent life form in the universe, and that could be huge. It could be, in fact, one of the biggest events in the history of the human race. So on one hand, it could be a wild goose chase, but hey, we have serious physicists believing that one day, if we do pick up signals from an alien civilization, it'll change the course of modern history. And with us today, once again, is Dr. Seth Shostak. Got his PhD at Princeton and Caltech, and is now the director of the SETI Institute, directing the work of scores of physicists and chemists and astronomers looking for anything resembling an intelligent signal from outer space. And he's following in the footsteps of astronomer Frank Drake. Back in the 50s and 60s, astronomer Frank Drake had the idea of searching for radio signals from intelligent life in outer space, intelligent enough to use radio to broadcast on. But the question is, there are so many frequencies out there. Which frequency do you dial into if you want to listen in on a conversation between aliens?
Well, that's actually a good point because, of course, the aliens haven't sent us a fax telling us where on the dial they might be broadcasting. So you have to sort of second guess what frequencies, what part of the dial makes sense. And that idea had already been explored, even though Frank Drake didn't know that, by a couple of guys who at that point were at Cornell University, a couple of physicists by the name of Giuseppe Cocconi, and Philip Morrison. Anyhow, these two guys had already thought about what frequencies make sense if you're going to send messages between the stars. And they said, well, look, there's kind of a natural answer to that because there's one frequency everybody will know, and it turns out to be 1420 megahertz on the dial. You might think, well, what's special about that? It turns out that hydrogen, which is by far the overwhelmingly most common element in the universe, hydrogen naturally emits some radio emission at 1420 megahertz. So all astronomers, of any sophistication in the universe will know about this frequency. So they said, look, that's a natural frequency. Everybody will have it marked on their radio dial. Let's try listening there. Frank Drake came to the same conclusion rather independently. And so the first experiments were done usually with a receiver that only had one channel. It could only listen to one channel at a time, just like your auto radio, and set that frequency somewhere near this 1420 megahertz magic frequency of the dial. Now, as time went on, this kind of experiment became much more sophisticated. Today, the receivers that are used for SETI listen simultaneously to tens of millions of channels at once because, you don't know exactly which frequency might be the one they're using, but they tend to look at that part of the dial around 1420 megahertz. Not always. Sometimes they'll do experiments where they're looking elsewhere, but usually you're covering maybe 1,000 or 2,000 megahertz around that frequency. So, it's a small fraction of the dial, but it seems to be a pretty good one. No one's ever come up with a better argument about where to tune.
Okay, now let's talk about Drake's equation, which is taught in every elementary astronomy course as scientists try to get a reasonable scientific estimate of the probability of intelligent races throughout the galaxy. So tell us a little bit about Drake's equation.
Well, the equation actually has an interesting history, or at least semi-interesting. Frank Drake had done that first listening experiment in the spring of 1960. So, gosh, that's 45 years ago. It was in April, I think, 1960. Anyhow, so that generated a lot of interest. I mean, he didn't find the aliens, but it generated a heck of a lot of interest. And so the next year, he had a meeting, also in West Virginia, at the observatory, in which he invited all the kind of professional scientists who were interested in this work. That total was like 10 or 12 or something. It was a fairly small number. And as an agenda, he was sitting around thinking, well, this meeting's coming up in a couple of weeks. I need an agenda. So as an agenda for this meeting, he wrote down this very simple equation, which has subsequently become known as the Drake equation. And all it does is try to estimate something called N, where N is the number of civilizations in our galaxy. Just let's confine ourselves to our galaxy that are broadcasting right now. The number of star systems, if you will, that are producing signals now that we could detect. Now, clearly, that depends on, well, how many stars are there in the galaxy, and what fraction of those have planets, and what fraction of those planets have produced life, and what fraction of those that have produced life have produced intelligent life, and what fraction of those have produced technology, and what fraction of those are actually on the air right now. Okay, so it's a whole string of terms. There's actually 7 terms in the equation. You can find it in almost any textbook on astronomy, and that's the Drake equation. And it would be great because it would tell you, what are your chances of success? I mean, if N is only a few, then the chances that you'll find these guys is pretty small. But if N are thousands or millions or some very large number, Carl Sagan thought that the value of N was several million. Well, if that's true, then, you have a pretty good chance of tripping across a signal sooner or later. So, unfortunately, of course, we don't know what N is. There are a bunch of terms in the equation that we simply don't know. So it's more of a talking point kind of thing than it is an equation that you can actually solve or use.
Other scientists say, bah, humbug. We had Professor Brownlee on our airwaves about a year and a half ago, and he said that Drake's equation is flawed. Flawed because there are new astronomical bits of information that show that, to get life is more difficult than we thought. He mentions, for example, that you need a large moon. Without a large moon, the Earth would eventually tumble in its orbit and over hundreds of millions of years, and that would make DNA impossible. He also mentioned the fact that at one point the entire Earth was frozen over. We were snowball Earth. And again, DNA would be very hard to get off the ground under those circumstances. He mentions you have to have a large Jupiter in order to clean out the debris of the solar system. He also mentions you have to be a certain distance from the center of the black hole at the center of the galaxy. Otherwise, you get fried by being too close to this very radioactive core at the center of the galaxy. But if you're too far out, then there are not enough heavy elements to create DNA and higher molecules. So, what are your thoughts? Is the Earth in some sense unique, as Professor Brownlee was hinting at, or do you think N is quite large, as Carl Sagan believed?
Well, of course, nobody knows, so everything I'm going to tell you is my opinion on this.
Okay.
Obviously.
Good enough.
If we knew the answer, we wouldn't be discussing it, but it's true. Don Brownlee and his colleague Peter Ward at the University of Washington up in Seattle wrote this book about 5 years ago called Rare Earth, in which they had indeed, as you indicated, kind of a laundry list of, reasons why Earth might not be just a run-of-the-mill planet. Earth might be very, very special, so special that, in fact, although there might be some other life out there, it's not going to be very sophisticated life. It isn't going to be intelligent life. And so our SETI experiments are kind of a waste of time. That was their thesis. And since this was reviewed, by the way, in the New York Times, this book got a lot of play. And but if you actually look at this laundry list, you find that the items on it are not terribly convincing. But let's take a couple of the ones you named, for example. The fact that the Earth has a large moon, which kind of stabilizes the spin of the Earth. Okay? Now, if we didn't have that large moon, and by the way, a large moon is kind of a rare thing. Mercury doesn't have a large moon, has no moons. Venus doesn't have a large moon, has no moons. Mars has a couple of moons. You could walk around in an afternoon. Tiny moons, they don't help. Earth, on the other hand, among the rocky planets, is the only one to have a large moon. Okay, and sure, it does stabilize the Earth's spin. But if you took that moon away, yes, well, the Earth wouldn't, just go completely nuts. Every now and again, the North Pole would come down to, Connecticut or some other place, that sort of thing. But it would take hundreds of thousands, maybe millions of years to do that, right? So it's such a slow event that even for complicated life like freshwater otters or whatever, right, they can just walk away from that problem. If you've got 100,000 years, before the North Pole gets to you, you have plenty of time to move. I mean, that isn't fatal to life. That's not fatal. It might be an inconvenience, if you had a society with a lot of cities, you might not want it to happen. But it's so slow. It's not fatal. Now, here's another thing in your list there. You mentioned we're fortunate to have Jupiter because Jupiter has cleaned out the inner solar system of all these big rocks that otherwise might, slam into your planet and ruin the whole day just the way it happened 65 million years ago, taking out the dinosaurs and 75% of all other species. Well, sure. But on the other hand, big Jupiters are not rare. We know that. In fact, all the planets we've found around other stars are like Jupiter are bigger. So big planets are not rare. But even aside from that, you could argue that maybe life on Earth would have gotten a little bit farther had we not had such a big planet as Jupiter out there. Because, in fact, if the dinos had been wiped out 50 million years earlier, we would be 50 million years ahead of where we are today. We'd have the cure for death, whatever. It would be, maybe we'd be better off. So I don't find that a very convincing argument. I mean, you can look at each one of these arguments of the snowball Earth. Yes, there's some evidence, although it's somewhat controversial, but there's some evidence that there was a time, a few billion years ago, when the entire Earth was encrusted with ice. But there was life on Earth then. And that life wasn't wiped out by snowball Earth. It just, had to sit there and, live at the bottom of the oceans for a while. But, a lot of life, well, all life was down in the oceans anyhow. So, it didn't wipe out Earth. It wasn't fatal. Okay, so all these things, yes, they might be an inconvenience or they might not be, but in any case, none of them stopped life on Earth. None of them stopped life on Earth. So I really don't think that Earth is really all that special.
Well, Professor Brownlee goes on, in fact, on and on and on, as I found out interviewing him. He also says that microbial life could, in fact, be quite common throughout the universe, but intelligent life, well, take a look at the dinosaurs, he says. We've had life forms with spinal cords and nervous systems for hundreds of millions of years on the Earth, but humans, only humans on the Earth, even on the Earth with such ideal conditions, it took hundreds of millions of years for humans to get off the ground. And even then, there were many times when humanity may have been wiped out. There were only a few thousand of us, 100,000 years ago to create the entire human race. The human race could have been wiped out many times during certain bottlenecks in our evolution. So he was basically saying that intelligent life is extremely rare, even if you have microbial life being common. What are your thoughts?
Well, he's right in that this is a controversial area. I think even more controversial than the question of whether you can get complex life on a lot of planets. I don't think that's so controversial myself. But just because I give you 1 million planets with life, right, and you let them cook for a few billion years, there is a legitimate question. What fraction of them will ever cook up something as clever as, as we are? and we are clever compared to most critters around, right?
That's debatable, but anyway.
Well, but in any case, I mean, we don't know because we still don't understand fully how, or even partially really, how intelligence evolved on Earth. What was it that produced intelligence on Earth? If it's a mechanism that was just very rare in the sense of being accidental or contingent upon a lot of special circumstances, then maybe he's right. Maybe you got lots and lots of life out there. Maybe Captain Kirk takes the Starship Enterprise out into space and finds lots and lots of life in the galaxy, but it's all stupid. Okay, that's one possibility. But on the other hand, all the studies that have been done about how intelligence arose on Earth suggest that, well, what drove it was nothing that you wouldn't expect elsewhere. And sure, it took a long time before you got this far, but you needed some preconditions. You needed warm-blooded animals with a high metabolic rate. You needed all sorts of sort of biological developments. And then, in the last 50 million years, which of course is fairly short in the history of the planet, but in the last 50 million years, a lot of species have gotten smarter. Obviously Homo sapiens, but, and obviously our simian relatives, right? Chimps are pretty clever. But, birds are pretty clever. Even octopi are fairly clever. Whales and dolphins are fairly clever. There's been an increase in intelligence among, a couple of handfuls of species in the past 50 million years. It isn't just one species that got smarter. Now, we got smarter than they did, but if you were to visit Earth 2 million years ago, you would have found that the smartest things on the planet were not our simian ancestors, but some white-flanked dolphins. They had the highest IQs, and they didn't leave a lot of literature, but they were the smartest things around. Mm-hmm. So it does seem that intelligence is actually kind of a fairly natural product of evolution once you get to a certain level of complexity. This is controversial, but at least the indications are that intelligence is not some sort of miracle.
Okay, well, shifting gears a little bit, we also had Professor Dan Wertheimer from the University of California at Berkeley on our airwaves a few years ago, talking about SETI at home. That is, on your home PC, you can get a chunk of this radio data and have your PC via its screensaver basically crunch some of the numbers to look for intelligent signals. What's been the progress for SETI at home in the last several years?
Well, SETI at Home was intended originally just to be a very short-lived project, maybe for a year or two, but it was so popular that it's continued. They expected, maybe 50,000 people, would download this free bit of software so that when they walk away from their computer, it's still humming away, that it would process a certain amount of SETI data that it would download from the servers at the University of California at Berkeley. Well, more than 5 million people have downloaded that software, mm-hmm. So that's, that's 100 times as many as they expected, and about a third of them use it at any given time. What they do is they distribute a little bit of the data they collect from the radio telescope down in Puerto Rico, the Arecibo radio telescope, which a lot of listeners may have seen in the movie Contact, movie GoldenEye. It's a great movie star. Now, they distribute about 1 or 2% of the data they collect there on the web for people using the screensaver. But the point is that there are so many people doing this with their home computers that it is by far the largest computer project, the largest computer, if you will, in the world right now. And those data are looked at extraordinarily carefully. So, it's really a very, very fine-tooth comb. They look at all the rest of their data right there at Berkeley using, the local Berkeley computers, but they can't look as carefully as they can at this small fraction of the data, which, are the prime data, if you will. Now, has anybody found something? Well, people find stuff all the time, of course. If you do this sort of work, and you're using a big antenna like the one in Puerto Rico, you find signals all the time. That's right. You got this huge antenna. It's connected to a receiver that has millions of channels. Of course you pick up signals. But, of course, the question is that ET on the line or is that AT&T on the line? Is it just interference from a telecommunications satellite or something like that? Now, what the guys at Berkeley do is they look at all the signals that have been found by people using their computers at home. And they look for those cases where a signal has been found more than once, in fact, more than twice. If a signal has been found 3 different times, right, not just by 3 different people, that doesn't count, but by, at 3 different times. In other words, the telescope was pointing at some spot on the sky and they find a signal, and then, 3 months later comes back to that same point, and somebody else finds it again at that same frequency, at that same spot on the sky. If that happens 3 or more times, then they say, hey, look, that's, kind of interesting from a statistical point of view. That suggests it's not just a noise spike. That looks like a real signal. And then they will go down to the telescope and will deliberately look at that spot on the sky for a long period of time, for a few minutes, whatever it takes, until they can verify whether the signal is still there. They have done that on several occasions. So far, no dice. But, on the other hand, it is quite possible that somebody running SETI at home could, in fact, find the signal that would entitle them to pick up a prize in Stockholm and have dinner with the king.
And that, of course, would be perhaps one of the pivotal events in human evolution on the planet Earth.
I think so.
Well, let me ask you now the $64,000 question. What do you, as an individual, think N is, N being the number of intelligent planetary systems out there, and where are they?
Yes, well, of course, I don't know what N is either, but I tend to agree with Frank Drake, who still works here at the SETI Institute. His office is down the hall from mine. And Frank is now, I guess he'll be 75 in another month or so. But he's still as active as he ever was. And he's a pretty smart guy. He's one of the cleverest guys I've known. And if you ask Frank, look, this is your equation. What do you think N is? He'll say, well, I think it's probably around 10,000, which is kind of a conservative number compared to Carl Sagan, who thought it was a few million. I think Isaac Asimov thought it was 2/3 of a million. So Frank is saying about 10,000. Well, if it's anywhere between 1,000 and, well, some bigger number, if it's more than 1,000, then that means that the nearest aliens are within, on the order of 1,000 light years, okay, to us. Now, keep in mind that if you look at the whole Milky Way galaxy, it's about 100,000 light years across. So this is, only like 1% of the way across the galaxy. 1,000 light years. That's far if you're trying to drive it in your Honda, but it isn't so far for a radio telescope. If that's the case, and it really is, it's up for grabs. Obviously, we don't know. But if that's the case, then our experiments should find a signal within the next 20 years, because within the next 20 years, we will have kind of searched stars out to that distance. So that's my bet. But on the other hand, we're not going to know the answer until we know the answer.
And what are your thoughts about, where are they? SETI so far has picked up nothing. Is that just a question of lack of sensitivity of the SETI antennas, lack of detectors, or is it because they're shy out there in outer space? Or maybe they don't exist? Or, what are your thoughts about why we haven't picked up any messages yet?
Yeah, well, this, I think that the answer is very simple. I think it's simply because we've not combed enough galactic real estate yet. But, there are people who say, no, the fact that you haven't heard anything yet means something. It means that they're not out there, because any society that was more advanced than ours, and most of them are going to be more advanced than ours. I mean, if intelligence really does occur on planets in a fashion that's not extraordinarily rare, then most of the societies out there will be much older than ours, because, after all, we're the new kids on the block. The Earth has only been here for 4.5 billion years. The galaxy's been around for like 3 times that length of time. So most of the stars out there are older than the sun. So if they're really advanced, then they should have been able by now to maybe colonize big chunks of the galaxy. Who knows? They should have been able to spread around. They should have, remote transmitters. They should be very easy to find, right? And the fact that we haven't found them sounds like some sort of paradox. In fact, this little argument is often called the Fermi paradox, because Enrico Fermi, the physicist, the Italian-American physicist, was the first to point this out over a lunch at, I think it was Los Alamos in 1950. But in any case, that's his argument. I don't think I buy into that. I don't think it's a matter of them being shy, being coy. Maybe some of them are shy. Maybe most of them are shy. But if only one society has a powerful transmitter out there, then we have a chance of success. I think the reason we haven't found them yet is that we haven't looked very carefully. And all of that is going to change in the next few decades, mostly because of the march of technology.
Well, my personal point of view is that if there's an anthill in the country and you're walking down this country road and you bump into this anthill, do you go down to the ants and say, I bring you trinkets, I bring you beads, I bring you nuclear energy and DNA technology, or perhaps maybe you step on a few of them?
Yeah, probably. I get phone calls just about every other day from people who have their own explanation of why we haven't heard anything, and it's usually because the aliens are put off by our environmental degradation and our, threatening one another with war and all that sort of stuff. But indeed, I think that from their point of view, none of that matters terribly much any more than whatever wars the ants are getting into concern me. They don't.
Mm-hmm. Now, another stream of thought says that we're looking in the wrong place. For example, take a look at email. Email is compressed, email is broken up and goes through many cities and then recombined at the other end. So if an alien civilization had even a primitive email system, and we were eavesdropping on it, we wouldn't hear much at all. The signals would be compressed in a way that we don't understand. They'd be fragmented and redistributed and reassembled someplace else in a code we don't understand. So we could be listening in to messages that are teeming with intelligent things in it, but we are simply too primitive to understand it. What are your thoughts about that?
Well, I'm sure there's a lot of truth in that. I don't expect that we are going to understand any of the messages, even to the point of being able to sort of break them up into the bits that that make them up. And it's also true that, there are all sorts of methods for encoding information, for sending bits around that are fairly sophisticated that we use. For example, your cell phone tends to use what is called spread spectrum technology, where the signal is spread all over the dial instead of being concentrated in one spot. That's very hard to find with a radio receiver unless you know all the details of their communications schemes. So, yeah, there are lots and lots of ways they could make the signal hard to find, but in the end it comes down to this. If they have a transmitter on, that puts a certain amount of energy somewhere in the radio dial, somewhere in the radio spectrum. And we don't worry about how it's encoded or what the message is or anything like that. We don't worry about the message when we do our SETI experiments. We're just trying to determine, is a transmitter on? We're looking for narrowband components to the signal. It's called lots of excess energy, if you will, at certain spots on the radio dial. If we find that, we, of course, don't know what they're saying, whether it's something profound or whether it's something trivial like used car ads. We don't care about any of that. We're simply looking for evidence that their transmitters are on because, after all, that's the proof that we're after.
Okay, now let's talk about flying saucers. Of course, the distances between stars are enormous. It would take the Voyager spacecraft thousands and thousands of years to reach the nearest star. But that's because, we're kind of primitive on this scale that we're talking about. Another civilization could easily be 1 million years ahead of us. And so the next question is there a law of physics preventing a civilization millions of years ahead of us from making contact with us? Is there any brick wall that prevents an advanced civilization from making contact?
Well, Michio, you're the physicist, and you know that there isn't. There's no physics that prevents it. Now, there may be some physics that makes it very hard. Conventional physics, if you use, rockets in the normal sense, the problem there is our rockets, of course, don't go fast enough. That they're more advanced. They can build better rockets. But when you get up to very high speeds, and you really do need speeds that are comparable to the speed of light if you want to get from one star to the next in less than a century, which sounds to me like something you might want to do no matter who you are.
Well, I'm afraid that's it for exploration. Once again, this is Dr. Michio Kaku, professor of theoretical physics at the City College. And our special guest today has been Dr. Seth Shostak, talking about the search for intelligent life in the universe.